Okay, what I want to go over today actually has to do with this stuff. We barely got any time to work on any problems to do with just basic simple harmonic motion. That's a mass on a spring or a pendulum. We just jumped right into doing energy and Hooke's law, okay, without really looking at the T equals 2 pi times the root of m over k, L over g, okay? And because today was going to be a short period and we weren't going to need a lot of it, I wanted to just kind of go over a few more of those things. So just as a quick reminder, okay, for any simple harmonic motion to occur, okay, the restoring force has to vary linearly with displacement. We've been going over that for a few days with all the Hooke's law and energy stuff, okay? But the things that can affect the period of a pendulum are length and, what's the other thing? Gravity, okay, which hopefully was verified by our experiment yesterday. As I know, I can't remember which class it was in, but a group or two came up to me and they're like, Mr. Coderre, we think we're doing this wrong. Nothing's changing. I'm like, then you're doing it right. Okay, the only one where you should have got any change in the period was for length. Okay, you should have got the same amount of time or the same amount of oscillations in 20 seconds for everything you did until you got to part C, right? Because they had no effect, okay, on the period of a pendulum. So hopefully that's what you got, or very close to what you got. You may have got small changes just because of measurement error and things like that. Okay. All right, for a mass on a spring, the two things that affect the period of a mass on a spring are the mass, obviously, because more inertia, more energy pulls it further, okay, and the stiffness of the spring. The stiffer the spring, the harder it is to stretch and compress it. So those two things would affect the period of a mass on a spring. Okay? So like I said, we didn't get a lot of time to go over problems to do with these two formulas, and I just want to make sure we know how to do that, because next week I'm going to give you an assignment on simple harmonic motion. We're essentially done. I have a little mini lab activity on Hooke's law I want to do as well, and then we're moving on to waves. Okay? It'll take us about 2 weeks to do waves, and then guess what? Yeah, we're pretty much out of time then, because your last day of classes is the 16th of June. So we're like right on track. Okay? We're just perfect. Okay? We should even get, I'm looking at probably 3 days for a final exam review in class. Okay, I cannot remember the last time I had 3 days for final exam review, but that'll be great, because then we can do 1 day for each of the first 3 units, okay, and really focus on those. That's the way it looks right now. It could change, but that's the way it looks right now. Okay. You know, if we get a snow day or something like that, don't laugh, because that could happen. Okay? We've had one in May before. Okay? It's great. Well, you guys haven't, but many moons ago it did. Okay. All right. So what I would like you guys to try here, because we didn't get to many of these. Okay. Is actually, sorry, the ones from the digital workbook. Okay. We didn't get to any of the ones in the digital workbook, so I'm going to circle the ones that I want you guys to try right now. Come on, I'll get my drop down.
There it is. Boy, my computer's slow.
And I want you to do the one with Elwin the bungee clown, but I blew it up too much and now you can't see it. Oh, this is going to mess everything up. And the one with Elwin the bungee one. Yeah. I would like you guys to give those 7 problems a try. I think there's a couple there that we'll probably need to go through. And there's a couple where I just like throw stuff and see if you can catch it. Okay? Or not use it, or in that case maybe. Okay, this is a formula that we barely touched on and never used. Period is 1 over the frequency. And similarly, this one's on your formula sheet, this one's not because it's the same formula. F equals 1 over t. A whole bunch of the questions I circled give or ask for frequency. So you will occasionally have this intermediate calculation, okay, that you may have to do. Right, but that was kind of the main reason that I wanted to go over some of these, just so that we remember frequency and period are the inverse of each other. Period is the time for one oscillation, and frequency is the number of oscillations per second.